Hello, my name is Roland Waits. In this video, the name of this video is The Chernobyl Mess. How about some truth? First off, any report that says that explosion happened because, and solely because, of design faults in the reactor is a bald-faced lie. In 1986, the International Atomic Energy Commission released a report that blamed the operators, and in 1992 they came back with a report that blamed everybody but the operators. And the facts of the matter are that the reactor was mishandled by one person in particular who was charged with doing a component test on a live reactor. They had this turbine test that they had to do, which was a spin down turbine test to see if they could derive enough electricity in 60 seconds to power pumps that put water to the reactor core to cool it. They should have done this test on a turbine connected to a similar pipe but not connected to an active reactor. They should have never done this on an active reactor. And this 1992 report seems to completely forget about how the reactor was mishandled. And it says, it actually says in the report, in not so many words, that any nuclear reactor that depends on human operators is bound to have an accident. Well, that's an interesting assertion, because as far as I know, every nuclear reactor in the world is handled by human operators. And they talk about there was an ability at Chernobyl, and then these are RBMK reactors. It's a specific type of reactors. And the Soviets, it was in the Soviet Union. It was in the Ukrainian part of the Soviet Union. Anyway, these reactors had abilities for the operators to shut down or otherwise circumvent the safety systems. And this report says that should never happen. That's, and I mean, you can't argue with that. I agree with that, but you should never do a component test on an active reactor. The irony here is this, after the fact, they went back and trashed the entire RBMK design, and yet there's never been another Chernobyl type accident before or since. And it sort of tells you what was going on there. So let's get down to brass tacks. Let's talk about the reactor design and the peculiarities of it. It's sad when you see people trash a design and they go after it. There were problems, but they weren't insurmountable problems. If the reactor was handled with respect and operated within the parameters that the reactor was designed to be operated in, there was no problem. And if the power level had reached a point where the reactor was blatantly unstable and the operating procedures that were in place were followed and the reactor was shut down, there was no problem. These reactors are kind of a strange animal. You have to bring the fuel in, you have to start them up, you have to get them up to speed, and then you have to operate them at a level where they're stable. And then once you're at a level where they're stable, then you're able to remove rods, raise and lower rods, and you're able to work with the reactor and make it stable. But you can't be, you can't be like revving the motor on a car here. You have to bring it up to cruise speed and keep it at cruise speed. And when you do that, it's a relatively safe design. So let's talk about this this design. I had it right here. God darn it. Where did I put that at? Here it is. Okay, let me show you the simplest terms what a RBMK reactor is. There it is. An RBMK reactor being heated by a hot rock. That's what it is. Only this enclosure weighs thousands of tons. This top weighs thousands of tons. People stand on this top, and it has holes in it so that you can put fuel rods down into it. And this brick is right here inside, and it's heated by the nuclear fuel. It's a very simple design in its most basic sense. But once you get looking at the design and the things they do to achieve the heat, manage the heat, and manage the environment around this core, you have a real appreciation that the Russians and the Ukrainians and whoever else helped design and run these things really do give a damn about what they're doing, that they care about the fact that this thing, that they're not trying to create a nuclear explosion, right? And they're not trying to create a nuclear holocaust of environmental damage. So that's the basic sense. I mean, you're heating water. There's a pipe coming out of here, goes to a turbine. It spins a turbine. The water cools off. The steam comes out. It spins a turbine. The steam cools off, creates a pool. Then you pump it back in the bottom here. You're constantly recycling the water. You have steam water separators up here, and you know your graphite block is inside of here. And you're managing the rods in and out of it, and this sucker's getting smoking hot. I mean, Wikipedia has a really good RBMK reactor page that shows you the fuel rods and some basics of how it's run. One of the things I thought was neat was that the environment in here is not oxygen, it's helium nitrogen. Now, why is that? The reason is because this whole thing is run under pressure, and they don't want to generate an explosive amount of hydrogen up here, and they don't want, they're using water to cool this thing, but they're not using water in the common sense that we know it. They're using water under pressure, and they're subjecting it to extremes of temperature and pressure, and it does funny things. And they produces hydrogen. By electrolysis, it produces hydrogen. Ironically, they pull the hydrogen off and run it down as a gas to cool the generators. And it's just really neat. They store the hydrogen in tanks there too to do that. There's so many things in this reactor that are advanced and designed to create a safe operating system. That if you follow the rules, it's a relatively stable reactor that will not get you into trouble. The one thing the Chernobyl accident did show the entire world, and it's incontrovertible, you cannot argue with this, is that every nuclear plant needs to have a containment system. They have to have it. I mean, you cannot have what happened at Chernobyl ever happen again. Now, I'll get into the nature of some passive containment systems and stuff, some sort of space age stuff at the end of the video, but for right now, let's just say they should have had some form of containment over this thing, even though there was an explosion that would have probably damaged the containment building. I mean, it's almost guaranteed, because it pulverized the concrete building when this second explosion went off. We're going to get into that too. Anyway, so here's your core. Here you're getting your steam. It's coming down to this turbine. It's spinning the turbine. It exhausts itself, turns back into water. Water condenses here. Here's a pump. Here's water here, and it sends it back into the core. Now, this is very simple, but you should look at the NSAG 7 report, and you should look down past, it's like 100, and I think it's 175 pages. But you should look down in the 150 page area and look at the drawings. It's past, there's a big section that's got Russian writing on it. And if you think that that's, oh God, the rest of the report's going to be in Russian, I won't be able to read it. Well, it's just a couple of sections of Russian attribution of information sources. And then once it goes past there, then you can start getting drawings of what the genuine core principles are, what the routing of the hoses are. I mean, you get drawings like this here. This came off the INSAG 7 report. You can see here's the core, and here's the separators. Here's the ECCS system right here. It's independent right here. And this is part of the ECS system too. And this whole system's designed so that we don't have a Chernobyl. So we don't have that explosion. I mean, it was designed to give auxiliary cooling to that core so that they could have time to get the rods into it and to cease the reaction and to minimize the heat buildup in the core. Well, there's a lot of sadness about that, and this report fails to recognize the consequences of turning the ECCS system off. I mean, and why would you do that? Why would you turn one of the most fundamental safety systems in a reactor off, and turn it off not for 15 minutes, but turn it off for hours? They turned it off at 2 o'clock the day before the explosion, and the explosion happened at 1 o'clock in the morning the next morning. And what were they doing for all those hours? And what they were doing was, first off, they turned that system off, and then they pressurized the entire reactor steam system, because they wanted to see Deadloft himself. I watched there's an hour interview of him after, it's like 4 years after Chernobyl, and he's talking about it in Russian. You can see his inflections, how he's talking, and he talks about going home, and you know, this is the most important test he's ever run in his professional life, but he's going to go home and take a nap and eat some food, and he'll be back later. Well, how does he know that he's going to be back later? How does he know that, you know, a half an hour later that he doesn't get the call that, oh, hey, you can turn your power down on your reactor? Well, the only way he knows this is if somebody's already told him, well, we're going to put this call out that this reactor's going to stay here. We want to put this test into the night shift. We want to put this turbine test into the night shift where there's less people to stand in our way at the turbine test, and nobody will ask us what we're doing. So that's what I'm thinking. But he has some absences that are pretty telling, and one of the biggest absences in his testimony on this YouTube video is that when it gets to what happened in the control room right before things blew up, he miraculously didn't have any input to it. He never speaks about his input. Now, after the fact, he talks about sending people out to check things out and all this stuff. But before the accident, he never says, I told them to do this and I told them to do that and they did this and that. He never takes credit for any of it. Alright. This is my second video on this. My first video was essentially blaming the electrical engineers for this, because my view was there's so much information here that's not present, and so many decisions in this INSAG report talk about a lack of alarms, a lack of sensory recording of any problems with the core. And I said, you know, if you're going to do a turbine test, and you know you're going to risk the reactor, and you know that you're going to create a potentially very bad problem, what you want to do is you want to cover your rear end so that at the inquest after the fact, should something happen, nobody can bring this up and say, okay, well, this readout said this and you ignored it. This readout said this and you ignored it. So what do? Well, my view was you talk to the electrical engineers and you tell them, first off, let's go to the core of what they were trying to do that day. And it matters. I mean, the INSAG 7 report doesn't even seem like it matters. But they were gambling the entire reactor so that this generator wheel would spin for 1 minute of free power. That's all they were looking for. This sucker weighs thousands of tons. You would not believe how heavy this sucker is. I saw I saw the weight of the generator and the weight of the turbine wheels, and it's thousands of tons. This whole system here. I mean, it's just incredibly heavy. So you can imagine what it takes to spin this thing. And not only that, I mean, generators have their own resistance inside of the stator that spins goes through magnetic poles. And like I said, I had another video here, which because of the drawing, primarily I had to take it off because the drawing was not accurate. Anyway, if you've ever spun a small electric motor or spun a small generator, specifically also a generator, when it spins through the poles, you'll feel resistance. They go, and that's a little teeny tiny thing. You can actually feel the resistance. Imagine that multiplied by 1,000,000 and how much resistance that is going through the poles, plus spinning the thousands of pounds of steel and exotic metals that's in this generator system. So it's no wonder that they did this test in 1982, 1984, 1985, and unfortunately they did this test in 1986. This was a fail, this was a fail, this was a fail, boom. The first test in 1982 they didn't get the results they wanted. They modified something in the system, and then they went to 1984, they got another fail, and then they did the test again in 1985 and they did another fail. And I have to wonder if in these 3 tests the reason it failed was because they saw a problem and they reacted, then they just simply stopped the test. They said, we're not going to risk the reactor. Come 1986, it looks like Deadloft has been approached by, I would say, the Communist Party system was a very overbearing system. I want to talk about Deadloft. He was born, his life story's quite a piece of work. And he was born to a peasant family that was in a poor part of the Soviet Union, and it was around a penal colony, a criminal colony, which in the Soviet Union a lot of people were criminals just for thinking differently. So he would have been indoctrinated by his parents to know very well what happened if you went up against these Communist Party officials. And his parents would have told him, look, you can either be on the good side or you can be on the bad side. So he, no doubt, was like, his whole life was like, hey, I'm going to stay on the good side of this argument. He became an electrical engineer. Huh? An electrical engineer. Huh? How you like that? Guess what? He became an electrical engineer that installed nuclear reactors on Russian submarines. So he had everything that's in this power system here. He learned in a Russian nuclear submarine in a microscopic way. I mean, it's all in a much more confined, condensed environment. Therefore, everything's much more important. Therefore, everything you do is more important. And he actually got exposed to a very, well, it wasn't low, but it was a medium dose of radiation. He got really sick. And I saw one report about his son dying of leukemia, which leukemia is caused, one of the causes of leukemia is radiation poisoning. So Deadloft might have hastened the death of his own son by going home sick as a dog. His son comes in, hugs him, and he's radioactive, and he hugs his son and he kills him. And when I saw that report, I was like, wow, man, this is a guy who has I would have a real bone to pick with Russian nuclear power, Soviet nuclear power, if they almost killed me and killed my son. But it doesn't look that way. It looks like he got over that, and then he moved on to the Chernobyl plant, where he became the deputy chief of Unit 3 and 4. He was a bigwig at the plant, and he was the person that the Communist Party officials reached out for and said, 1986, I want to have a positive result on this test. Okay, so when you let's talk about the turbo generator. When you're spinning the turbo generator, what makes it spin? Well, it's high pressure steam, and that's what this core is all about. It's about, let's boil some water, let's make some steam, separate the water out, make the steam come down to the generator, spin the wheel, and then that's how we make our electricity. The whole point is this: to make electricity. That's what this whole make electricity. That's what this entire massive installation's about. Part of the give back on this, unfortunately, is that they can also get. I'm not sure if they can do it with the RBMK. I think I did see a note where they said they could get nuclear fuel for weapons out of it. But that's not what it's designed for. It's designed to make electricity. And it's pretty good at it. It's pretty, when it's run right. He said something, millions of megawatts. Forgive me. Last video I said milliwatts over and over and over again, and the guy busted my chops. I loved him for it because he said, "Oh, that's a big reactor, milliwatts, huh? What is it, like the ant reactor? It's megawatts." Okay, I'll put that up here. Megawatts. Everything's in megawatts. Anyway, so they were doing this spin down test on this because they wanted to get power to these pumps. Free power is that turbine spun down. Now remember, these things weigh thousands of tons. It's bigger than two houses, you know, of two normal American houses. So how do you make this thing spin longer? They were having problems. Here's another thing to remember too. These pumps, they have an electric protection circuit. And if the power drops below, I think it was 15%, no, 75% for 5 seconds, or 15% of the nominal voltage needed to run the pump, the protection circuit cuts in, and then the pump will not receive electricity, and the pump will go into a spin down phase. And what brings that, the oddity of this type of protection circuit is, depends on how it's made. I don't think that it cuts back on right away. I think you have to achieve back to your nominal voltage in order for it to cut back on. So once this pump cuts off, now they have diesel generators that will power these pumps to cool the core. But the problem was they had a 1 minute to 1 minute 15 second delay till the diesel generators got up to full power. And they felt that wasn't acceptable to the core, because in a full power scenario with the core smoking hot, that 1 minute would make a difference, a massive difference. Something they never talked about in none of these reports, none of them, they never talked about it, is the simple physical act of running a control rod down into a tube, and the clearance in the tube getting distorted by heat. I mean, you know, when it heats up, they have everything has a expansion and contraction coefficient to it. Most things, well known what that is. Okay, and in a graphite core situation, no doubt they engineered in the least amount of expansion capability in the product as possible. That's part of having a helium-nitrogen environment. That's part of working in the core to make sure you don't have hot spots. And they had sensors all over this thing. I mean, the characterization is of this RBMK reactor as a piece of garbage is a blatant insult. It's not a piece of garbage. It had some design problems, but the design problems are not what caused the explosion. What caused the explosion was they hot rodded the reactor. Anatoly Deadloft was tasked with hot rodding the entire reactor to make this sucker spin faster. All right. Anyway, the way you make this spin faster is you have to, first off, you have to make it as easy on this to spin. Okay, so if you have water in the turbine system, it would be nice to have a vacuum here. Vacuum going this way. And then it would be nice to have more steam initially going this way. And I have to tell you, I saw the schematic, and like I said, I'm going to raise it up here again. Here's a schematic of everything. This is the whole ECCS system right here. But I looked for a way that he could back channel that steam. And the reason I say that is because I'm going to tell you something nobody's ever even thought about talking about. I think Deadloft was trying to cheat. I think Deadloft had talked to his steam engineers, and he was an electrician himself, and he knew about the behavior of the RBMK reactor system when it was shut down. He knew that they had a pulse. When they dropped all the rods, they had a pulse that ran through the steam system. And that was because of the rods pushing down in the core and pushing all that extra pressure into the core system and out the top of the core. I don't know how he could back channel extra steam by dropping the rod, but I think that's what his little trick was. I think he was going to run this sucker up smoking hot, and I think he was going to drop the rods, and when he dropped the rods, it was going to act like a plunger, pushing down and push that excess steam out of the core, and it was going to go somewhere to reach this turbine to achieve that pulse that they needed to get a successful end result to the test. So when the AZ5 button, or the EPS5 button, whatever you want to call it, was pushed, he was actually going, great, here it goes. The rods are going down. I'm going to get my steam pulse. The reactor's going to shut down. It's going to be hot, but everything's going to be fine. And obviously he didn't know, or at least he didn't let on that he knew, that these rods had a big problem at the end of their, sitting right at the beginning of their insertion into the core. I mean, these rods had boron. This is boron here. But at the front of it, they had a graphite deflector. And what this did was, that was supposed to push anything that was in the channel out of the way so the boron could get down into the core. I don't know if they were concerned about the boron being fragile or something at the... I have a feeling what they were concerned about was that some sort of breakage at the end of the boron rod, which would sort of cycle itself sideways up into the channel and then jam the rod in place, and that was something they just couldn't have, and that's why they did this like this. But if you have a graphite core that's superheated, and you're causing deflections in the channels, it's never going to go down. It doesn't matter if it has deflectors on it or not, because if you've got a channel that goes from this to this, or where the actual rod, the actual channel it goes into gets so tight that the thing jams, it's not going to go down. And as far as I could tell, these rods went down by virtue of their own weight. They didn't force them down. They talked about when they pressed the EPS5 button that the rods went half the way down and stopped. And then I think it was Akamov pressed, it might have been Toptonoff, but somebody pressed the clutch to let loose the rod so they could go down that much further. And then Deadloft says he wants them to go into the core and push him down manually. I'm like going, wow, that's really crazy, because the core is, by that time the core is in pieces. But the thing I'm seeing in this report here is very disturbing to me, especially this NSAG 7 report, where it says that the ECS system shutdown didn't have anything to do with the reactor explosion. Well, you have to know that that reactor was compromised before those rods ever went down there. If that reactor was not compromised, those rods wouldn't have got stuck. They would have gone down and stopped the reaction, and there wouldn't have been an explosion. But even more important than that, at 12:28, a full hour and 15 minutes before the accident happens, Akamov and Toptonoff see a 30 milliwatt thermal power level in the reactor, and they're down. Let's shut it off. Let's shut it down. And Deadloft says, no. No, we have to do this test today. We're going to do it today, no matter what. And that was the defining moment in Chernobyl history, right there. That was the defining moment. That was the part where these two guys should have said, "Screw you! I know better than you. I'm not going to blow this. I'm not going to destroy this unit. You can take my job. Somebody else will do it. Somebody else will do this." And they should have pressed that button. Now, there's no guarantee at that point that those rods had gone down, because they had been hot rodding this core. It's pretty obvious, since they turned the ECCS system off at 2 o'clock the day before, that they had been running this test. They had been running preparations for this test all day. They've been trying to find ways of channeling steam and dropping water out. Who knows how they did it or what they were trying to do. And I still say that Deadloft, being an electrical engineer and a nuclear sub, he had full access to the pathways. There's a I think it's called SCARS system, which remotely records all the inputs for later analysis. Well, this test said, well, there was never a indication that the ECCS system would ever have activated. Gee, I wonder if that was because Deadloft went and he knew where the pathways were, and he just took a wire off a terminal. That's all you got to do. You take a wire off a terminal. And they had lots of places in that reactor, in the electrical panels, where they could bridge critical pathways. And I saw reports that said, well, it was done so they could cheat stuff. No, it's not done. It's done that way when you have unreliable parts in a reactor. And what you do is you put a part you know is good in the channeling. Oh, look, I'm getting the same reading, so okay, I'm good. You know, or I'm checking this out. So you put it up there, you go, okay, good, we're good. We're getting the right amount of resistance. The meter's bad. So it's a diagnostic tool. It's not there for people to jump or across things and make them disappear, but it looks like that's exactly what Deadloft did. And as far as him going home for 2 hours or 3 hours and going to sleep and eating some food, that's a bunch of crap. And he's bought that. Now, had they done a forensic analysis, I mean, they couldn't even go into the plant. It was so damn deadly. So all of his evidence of what he's done has probably been destroyed by now. But it might not have. It might still be there if they went to the wire channels in the Chernobyl plant and were able to see places where the wires were cut. But listen, a small nuclear explosion went off in that place. So I would say that all of his handiwork has been destroyed. But, I mean, he left after, I mean, they turned this ECS system down at 2 o'clock. It lists the exact same time. As soon as it lists that the dispatcher for the grid said, you cannot turn Unit 4 turbo generators off at this time. We need the excess power. Now, this isn't something that happens like magic. They would have known that at the end of the month that they were going to have this type of situation come up. They would have known what the duration of it was, and they should have never turned this system off. I don't know what was the whole purpose of leaving a fundamental safety system off of a nuclear power plant for so many hours. And for the INSAC report to say, well, it didn't have anything to do with it. Yeah, it kind of did. I mean, if your reactor is overheating and then the ECCS system says, hey, the reactor's overheating, boom, and kicks everything in, you get extra water in, you get a signal to, you get all kinds of alarms and stuff that comes on, and it notifies the workers, hey, the ECCS system is turned on, we have an emergency, it's time to shut the core down, and they start dropping rods. And you do this before this core gets so hot that the channels get warped. Because once you compromise this core, once it gets so hot, those rods will never go in there. And I mean, when they hit the 30 milliwatt level at 1228, they created a real problem in this core, and it's called xenon poisoning. And what this does is, this low power level, the core is always making this thing called, I think it's Xenon 135. It's always making a gas called Xenon 135, and that is a great moderator of neutrons in the core, which means it lowers your power, your ability to make power. When the core is run at 700 megawatts or above, the core is hot enough to burn that off, and it changes it to 136, which is inert gas as far as nuclear power is concerned. They want this to change to this as fast as possible. But when the core drops to 30 megawatts, you don't get this self-cleaning action. So what you wind up with is you're flying in the blind here. And the INSAC report said the core was so large that in many places in the core it acted more like not one reactor but several reactors in one. And what they said was that there was this is another thing. When you get to this water cooling situation in the core, it gets very problematic because you have to work it a certain way. It has to the water's inherent physical properties have to be obeyed. When I say that, you have to understand where the boiling part is, where the entry part is, and what the phase is all the way through the core, how it works through the core. If you disobey the way that this change happens in the core, you start bringing the boiling part of the water farther and farther down in the core. And what do you get when you get boiling? Well, you get boiling, suppose this is a glass of water, okay? And you got a neutron hits the water. Actually, there's water in there, you can't see it, but it hits that and it slows down and it comes out the other side, slows down. It doesn't have as much energy. Now, if you have boiling voids in it, when the water comes, when the neutron hits that, it hits that void. That's an airspace. It hits it, boom, goes through that. Hits it on, boom, goes through that, and it goes right through that. It doesn't slow down as much, and that's the danger. You wind up with a situation where you start boiling water off, and you're actually inviting more and more and more neutron velocity and action inside the core. And this creates heat, this creates more reactivity, and it tends to be a cycle. It creates a cycle. And you never want to get to that point. They fight this in later versions of the RBMK reactor. They fought it by putting more absorbers in, more absorber rods in, and they increased, this is an irony, they increased the enrichment of the fuel rods from like 1.6 I think to 2.0. And because they were making more power and they had more absorbers in the core, they had a more robust reaction that they could manage, and it was actually safer, which is kind of ironic. But it was also more expensive, less economical to make power out of, and it kind of put a real dent in their power production plan, because all of this is based on making money at a certain level per kilowatt. You can't, nobody wants to spend, $100 million a kilowatt. They want to spend $1,000 a kilowatt, or however they have to spend it, So anyway, this was a mess. And the sad thing is, the International Atomic Energy Agency pretty much absolved the plant operators of all responsibility for this terrible event. And that's just not true. That's just not true. RBMK reactors are still operating in Russia, as far as I know. They're the only nation in the world, I think, that has them. India might have some, I don't know. But anyway, they're being operated relatively safely, as far as I know. But this thing, if you get into this like I did, I printed off probably 300 pages of information, because it's all on the internet. You can get it from WikiLeaks. You can get, where is my man's book here? Where are you? Here we go. The Chernobyl reactor design features and reasons for accident. By Mikhail V. Malko. You want an insightful description of everything that happened in that accident, and you want really good information from someone not wearing a mask, get to this and download it. It's who knows, I think it's like 17 pages maybe, but that's my copy of it right there. And just read through that thing and just be really saddened, because Deadloft he should have never done this. And when you look at his life, and he was born to poor parents, they were raised in farmland around a penal colony, so he knew about what the communist system would do to people who spoke up. He was an electrical engineer, went to work on Soviet submarines, putting reactors in. He got nuclear poison, radiation poison, and got really, really sick. His kid got leukemia and died. He went to Chernobyl, and I caught myself feeling sorry for this guy. I look at the guy. I mean, you look at the guy, and he looks like a proud Russian guy that was just trying to do his job. But then when you go on this site, let me do a little clean off here, because I think we've done enough with this here. I mean, they remove rods. They say this test started at 123.04, but there are indications in some of this literature of pumps being turned off like a half an hour before that. And then there's indications of pumps being turned, all the pumps being turned on at one time. Which the problem with that is, if you get too much velocity through the pump system, it doesn't go through the radiators slow enough to take the heat out. So you return heated air, heated water back into the core. This system, I mean, helium nitrogen environment, the core, it's just a beast. It's a wonderfully technically complicated piece of work. It's not something that Laurel and Hardy made, as the NSAG 7 report seems to think. And this report, in the language of its writing, and it's done by an atomic commission, is saying that nobody's qualified to run nuclear power. They're talking about there's no laws governing it, you can't trust human beings with it. They're actually saying that in the report itself. If you read in between the lines, they're actually throwing themselves on their own petard here. Not the Russians. Never a safety test, always a component test. The ECS system, when it was shut down, they should have shut the reactor down. That should have never happened on an active reactor, ever. As soon as that system gets shut off, those rods should have been dropped into that core, because you've taken away one of the major safety systems in the reactor, and that's not permissible. That should have never happened, and it sure should have never happened at 2 on 25th, and then ran all the way to 1:45 in the morning, 1:23 in the morning the next day. Deadloft. I'm going to get to this next point. Let me clean this sucker off real quick. Clean it off. Yeah, that looks clean. But it's just terrible, and I just hate it when people do things and other people come up and they go, well, you know, yeah, he ran over 300 people with an 18-wheeler, but it was the 18-wheeler's fault, you know? I'm like, hold on a minute, guy. It's like driving your car down the sidewalk, and then the police come up and go, well, you know, driving your car down the sidewalk at 100 miles an hour and killing people, and then the police come up and go, well, we never told them that driving a car down the sidewalk at 100 miles an hour will kill people. Well, that makes it all better. Okay. Let's see if I've managed to lose all of my freaking markers, because I got the demons with me today, bro. Woo! Yes, sir. Oh, I got it right here. Here we go. I got another one too. All right. If you go on this site, Getty Images, do not reproduce pictures. $500 each. Now, you've seen these pictures, but Getty Pictures has a license for these, so they get paid for them. So you can look at them, but don't download them, don't reproduce them unless you want to pay them $500 a picture. I felt really, I was sort of getting this warm feeling in my heart for Anatoly Dyatlov as just being a downtrodden guy. And then I went into here looking at the pictures, because I wanted to find pictures of that reactor, because I wanted to understand what the explosion characteristics was. And then I found pictures of all kinds of devastation of people that were affected by the radiation. And specifically, I found several pictures of deformed babies that were born with deformed throats. One unfortunate female baby was born with her whole anus was hanging out the back of her rear end. The doctor was holding her up. And I don't feel so sorry for Mr. Deadloft anymore. I really don't. As a matter of fact, I think he's a piece of crap. And it's not a Russian piece of crap. He's just a piece of crap. I mean, putting a nationality on that's just bullshit. That's just a human being that knew the risk. He knew the risk. He lost his son to leukemia. And he knew the risk. And after the fact, he was trying to save his ass. And I mean, you know, this is coming from the mouth of an American, so I'm never going to be put in that situation. So therein too is a problem too. I mean, I'm never going to be in a situation where if I don't do a test, they're going to send me to Siberia or shoot me. But they screwed with that reactor. Deadloft himself, I suspect, disconnected wires that would go to the SCAR system to record what they were doing so that he would be protected. And the information that came after the fact was all tainted. Because if let me tell you how you can make a meter not show an over reading. All you got to do is put a resistor in the line. If you put a resistor in the line that feeds up to a certain milliwatt level, if you put that resistor in there, it'll until it burns itself out, it'll just show that power level on the meter. So it could be getting twice the power. The resistor will heat up, and as the resistor heats up, it'll actually become more resistant, and then the power, what you see on the dial, will start coming down. So you're sitting here, oh look, the reactor's doing fine. Look at what my reading is here. When in fact it's getting twice the reading or 3 times the reading, but that resistor's sitting in the 2 checkpoints. See? I mean, Deadloft said he had went home for 2 hours, 3 hours, and then Deadloft left the control room at a very crucial point and came back later. So he had ample opportunity to do whatever he had to do to cover his own butt about what was about to happen in this reactor. And I'm still telling you, the timing of that AZ5 button being pushed, I'm telling you, it sounds to me like Deadloft was trying to get those rods to push a boost of steam down the line and force it some way through the lines to the turbine to make it spin that last 30 seconds that they needed to make the test work. I'm just so sad for all the people that have suffered through this. Let's just go through the explosion one time. I mean, the last time I drew this, because I did a video before, and last time I drew this, I drew almost looked like a containment vessel on top. I saw the pictures of the exploded building, and I saw something that looked like not a cone. I wasn't trying to show a cone over the reactor, but the cap itself looked like it was above the worker, and that not they were standing on. But this is where the cap sits. Here's where the core is. There's pipes right here, like this, and this sucker is massive. I mean, it's 1,000 tons. This is 1,000 tons. I saw numbers on this of being 1,000 tons to 2,000 tons. And you got a machine here that crane that feeds fuel into these lines, and I would assume also can put absorber rods in there too if they need them. And they go down into the core here, and this is all water through here. going up through here. You know, you got your water coming in this way, going in, steam and water going out. All of these fuel rods in here, all of these absorber rods in here are tied to a tile each in this top. My assumption is that there is the tile is like this. It probably has two electrical contacts here, so when the tile goes down into the square, those two electrical contacts touch. This is a motor. This is a cable. And this is the rod, be it fuel, absorber, or other, because they had several different types of rods in there. And this fits into a receiver in this cap. Now the way this cap is designed, it's like this and like this, and all your fuel rods and stuff goes in here. And this is a massive, massive, massive concrete piece. And I understand this is steel, and I could be wrong about that, but I'm doing the best I can. I think that's steel. But they're all hanging right here, like this, okay? And you gotta understand that this is all steam under pressure. And I had to laugh when every time on this HBO special that they have for Chernobyl, they said, "Oh, how does a RBMK reactor explode?" Well, dumbass, you're dealing with steam. So anything that deals with superheated steam can explode. They had a real problem with that with locomotives. They had a problem with that with steam generation in houses. They have a problem with that today, and that's one of the #1 things that steam fitters, union steam fitters, deal with. Is, you know, you always want to have a check valve system where excess pressure goes. I'm not going to go through all of the things they shut off. I mean, they shut so many safety systems off before this thing blew up. For that INSAG 7 report to say that this was bound to happen because of design failures, that is a bald-faced lie. That is a bald-faced lie. It takes the responsibility for those people's actions from themselves and puts it on the designers. The designers put the safety systems in there. They were not the ones who turned the safety systems off. Anyway, so this thing got smoking hot. Now remember, since 2 o'clock p.m. on April 25th, the ECCS system was off, closed. You should see, this is a neat little, this little box right here, that's a neat little box, because that shows you the steam coming out of all of the lines, coming over to this collector, and this is wide open. You know why that's wide open? That's because the steam is generated here, they lower the velocity of the steam coming out, it shoots up here and shoots out. And according to testimony later after the accident, they were used to hearing steam venting. It's quite a very loud and painful sound if you're close to it. Well, they had turned that system off. So now you've got this boiling plant reactor that's been recycling heat and pressure for friggin' hours. So this sucker here, you get this, the boiling of the water is going lower and lower and lower. You got this poison reactor here with the xenon in the middle of the core. So what you've done here now is you've got 1, 2, 3 sections of reactor. Okay, and I mean, I'm not smart enough to understand all the peculiarities of it, other than the fact that you're going to create a situation where once the boiling gets down here, this is a very dangerous situation, because you get into this cyclical heating arrangement. Heat, boil, heat, boil, heat, boil, heat. And the same thing is heat, boil, heat, heat, boil, increase reaction, increased heat. And this doesn't happen in seconds. This happens in tenths or hundredths of a second. Once it reaches a certain point, once you so destabilize the cooling of this core that you lose the ability to control what's going on inside of it. For them to say that the ECCS system turning off had nothing to do with this is a bald-faced lie. And all the other safety systems. I mean, they changed the boiling set points in the steam separators. They changed several other parameters. They were playing all kinds of things, all designed to get this turbine to spin. You know, they got it to spin all right. It spun its ass right out the building. Anyway, let's get to the explosion. Okay, so they do the AZ5 button, and the rods, which are supposed to go all the way down like this, and then that displacer is supposed to be down here at the bottom, so you get a full penetration of these rods. They start absorbing the neutrons, and you get this cessation of reaction, and immediately it's the same thing as shutting the reactor down. That's where you want that to be. Instead, what they get is this. They get this, and they get this. You get it stuck, and they get this displacer right in the middle of where this xenon core situation was. Now you've placed so much increased reactivity right in this section of the core. Immediately you boil the water away and you dry the core out. And what you've done is you essentially took an acetylene torch to this part of the core. You just cut it right in half. On top of that, now you've got this steam situation going on, and what happens is, no doubt when they put this in here, they drop it down like this. Well, of course the mounting, everything is sealed. The mounting bolts fail. Everything fails because there's so instantly, there's hundreds of thousands, maybe millions of pounds of pressure on this cap. And it pops up. And this is what the first explosion is the steam popping up. The steam pops up the top. And as it does that, it shatters that damn graphite core, because graphite is fragile. It's not something that intrinsically is an extraordinarily strong stuff. So now you got this top that's up like this. All of these tiles are holding these fuel rods and stuff like this. And you got to understand, by the time this happens, we're talking about tens of thousands of degrees in this area right here. And they touch, and that's where your secondary explosion occurs. And this is the big bad one. This is the one that sprays shit everywhere. Now, they got kind of lucky, I guess, because if you look at the explosion of the reactor, it was a low-level explosion that went like this. A lot of it went, the force went like this. And like this. And that's where you get, it just pulverized all this concrete, pulverized it. And if you look at the building, the turbine building, that's like, here's the chimney. Look at this turbine building, you'll see that the tiles on the top of this building over here are down, but I'll bet you there is a huge amount of, I call it the Russian nuclear shotgun effect of stuff right here. And unfortunately, this is where a huge amount of nuclear fuel got ejected. And I mean ejected not only in a direction like that, but I mean in a direction like this. I mean up into the damn stratosphere. And it's so sad because thousands of people, tens of thousands of people were affected by this. Actually millions of people were affected by this, but tens of thousands of people died because of this. And we'll never know who they were, and they'll never know that this affected them. But when you look at this, how this happened, this 2,000 ton, I'm surprised this 2,000 ton piece of hardware stayed in one piece, but it did, and it fell over. The fact that it didn't go far tells you that it was not of what type of nuclear explosion it was. And I want to hit one last thing and then we'll be done. If you look at an overview picture of the Chernobyl facility, you get this kind of kidney looking thing. You get this island out here. Here's the Chernobyl facility. Here's Unit 4 right here. And if you look at the overview picture of it, of the building, and you look at where that reactor core was, and you look at where this top is, it's sitting like this. And when that thing blew up, it shot garbage just like that. So it shot it in this direction, like right here. And it shot it literally. This is a picture of the radiation contamination done by the CIA, so I'm going to give them credit. Thank you for publishing it. I'm giving them credit on this. There is a Chernobyl plant, and there is a huge amount of nuclear fuel contamination. It blew that crap 100 miles away. When that top came up like that, I mean, it's amazing. I mean, here's your Russian pot, goes up like this, boom! And the shit went that way. And the thing is, if you look at an examination of how the core, how the top landed, okay, and how the core failed, because they have, in this INSAG 7 report, they have a graphic picture of, it's a force picture of where the failure was in the core. But you can tell that what side, if I could get to exact locations of stuff, this side was probably cooled better, more stable, or I'm sorry, it would have been this one. This side would have been cooled better, more stable. This side would have been less stable. And that's why you'd have more heat on this side. It would have raised the top up and made the angle like this. The fuel rods would have, the core, the graphite core would have been destroyed by the steam explosion, by pressure. The rods pull up, all the rods pull up, they all come together, boom, you get this reaction, and you get all this crap that just goes 100 miles away, and nobody's life is the same. They mentioned scenarios online about that there's no fuel left in the core. They mentioned that no graphite was burning in the core. Well, something was burning at thousands of degrees. There was testimony from one guy said he's a concrete worker. He's working at Unit 5. It was like 500 meters away, and he said that he heard what he thought was a steam explosion, and then he saw this bright blue light and a massive explosion. Well, the bright blue light shows that the temperature was 10,000 degrees Fahrenheit. And they also talk about after the thing blew up, they had this bright blue laser-like beam going straight up in the air from whatever was burning down here, and I submit to you that that was pulverized graphite and nuclear fuel that was in a very unusual, and like I said on the Chernobyl special, never before seen on Earth situation. Hopefully we'll never see it again. Now, let's get into a little discussion about containment. Okay, the statement was made in one of these reports, I think it might have been in Malco's report, that containment in a situation like this with the explosion wouldn't have made any difference. Well, anything that slows velocity down does make a difference. Containment in this situation, if you could put, I mean, this sounds crazy, I know, but if you could put rollers filled with some form of Kevlar-like fabric and put rockets on it to shoot it over the building, or just something that would cover the building over to contain this debris from getting up into the atmosphere, because this thing belched pollution for weeks, and it messed up a lot of people's lives, millions of people's lives. Chernobyl is proof that containment needs to be done in all nuclear facilities, but it's also proof that never again should any nuclear facility conduct parameter tests in an active nuclear reactor. The components, if they are ascribed to be defective, need to be removed and replaced with components that were proved off-site. You cannot risk this ever happening again. I just can't believe that this NSAG 7 report said over and over and over again this was inevitable. No, it's not inevitable. I mean, Deadloft was assigned to get one thing done, and that was that turbine test done, and he didn't give a damn about what he did to do it. And here's another thing too. Let's put this all in perspective. I see anecdotal evidence of Deadloft in this testimony. I see, when I check this out, all the major reports, I see nothing about mention about, well, Deadloft said to do this, and Deadloft said to do that. In Malco's report, it's there. But in other reports, I don't see anything about that. Deadloft certainly never volunteered anything about it. But Deadloft also didn't volunteer what he was doing at the reactor for hours and hours. He disappeared. Oh, I went home, I went to sleep. It's the most important thing in my life, my entire professional life. But I went home and I went to sleep for 2 hours and I ate. Oh, and then in the middle of the test, I left the control room. Yeah, okay. All that makes no sense. So, and the after the fact, the nuclear industry is terrified because nuclear industry wants to propagate itself. It wants more nuclear reactors. It wants to assess that this would never happen at an American reactor, when in fact we've had lots of accidents at American reactors. We've had releases of radioactive steam at 3 Mile Island. We've had people get killed from radiation poisoning. it just hasn't been at the scale of Chernobyl, and good God, let's never have that happen. So the bottom line of this Chernobyl thing is, if had Akimov and Topinov pushed that AZ5 button and shut that reactor down, all these people, none of these people would have died, none of these babies would have been born radiation poisoned and defective, and none of this would have happened. It has nothing to do with design failures of the RBMK reactor. It has to do with failures of people to follow the rules. And the INSAG report says, one of the things the INSAG report 7 says is, well, there were no rules about, there were no regulations that for them to follow. It was just suggested that these were guidelines. Well, you know, I mean, that's kind of like saying, if you jump out of a airplane with a untested parachute, you know, bad things will happen, but nobody ever tells anybody to do that. I mean, you're supposed to know that you're supposed to follow these operating guidelines, and they just didn't do it. And the sad fact is they all obeyed the power structure, and the power structure at the plant at the time was Deadloft. And Deadloft shake and bake that reactor, and look, this crap started the day before at 2 o'clock when they turned that ECCS system off. So there was more than Deadloft in play in this. There's people that are still alive in Russia that's had a lot of input in this. And nobody's ever gone back and said, okay, what were you doing that day? What did you turn off? What did Deadloft tell you to turn off? Did you put any jumpers into any transfer points up to the SCAR system so that information wouldn't get through? Did you see Deadloft at the plant instead of being at home? I mean, it looks, I mean, this is a beautiful sabotage, but I don't think that's what he was after. I think that he thought that when they pressed the AZ5 button, that those rods were going to go down in the core. He was going to get a pulse of steam through whatever back channel they could construct to get to that turbine. They were going to get their spin down test done. Everybody's going to be happy. The reactor was going to be mildly heat damaged, but okay. And everybody's going to be fine. But when those rods stuck, because the core was superheated, because they've been screwing with it for hours and hours and hours and hours and hours, and that's why it happened, because they were screwing with it for hours and hours and hours. I mean, the INSAG 7 report's an insult. It's an insult to anybody who has a brain, and I have a brain. It's a bunch of bureaucratically written crap. The first test that said the people who ran the reactor were at fault was right. So just don't let your life situation get you in a situation where you know you're doing the right thing to help people, to save people's lives, and you are forced by power above to hurt people. You know, sometimes you got to say no to the boss. Sometimes you got to say, no, we're going to press the AZ5 button early. We're going to shut the reactor down. If I go to Siberia, I go to Siberia, but you won't be killing people on my watch. And this plant will be standing. I'll walk away with the plant standing. You might blow it up later, but you're not blowing it up on my watch. And push that button. So let's just hope this never happens again. Let's hope that we've learned our lesson. And one of the biggest lessons of Chernobyl is nuclear power plants always have to have containment facilities. They always have to have containment facilities. Always. They have to have something to keep airborne pollution from getting away from the plant. And always, all the safety systems have to be engaged and working, or the plant must be shut down. Not negotiable. That's not negotiable. Let's hope we have a safe from here on out with our nuclear power plants, and that these commissions who write this crap can choke on it. What you do matters.